Alright, so I'm going to try to walk you guys through the first experiment that you will be doing, and that is the tennis ball laboratory, or at least part one of it. So the idea for this laboratory is you're going to drop a tennis ball from different heights, let it bounce, and then figure out how much energy it lost in the bouncing process. So if no energy was lost, the ball should bounce back up to its original height. And while it bounces, energy is lost through sound and heat and other forms of deformation in the ball. So we're going to discuss how to do that, how to set it up, and how to work through the one calculation that you have to do for this laboratory. So the first thing I'm going to do is pull up the assignment to go through the expectations for the assignment. So to do that, you go into my class, and in Unit 1, there should be Tennis Ball Experiment Day 1. On the front page is the rubric. I'm not going to look at that yet. I'm going to go through the expectations for it first. So if you click View Attachments, you can open up the laboratory right there. So you pull up that document, and all of my explanation and expected procedures are in here. So first of all, you can use any object that bounces consistently. I'm using a tennis ball, but you can use anything you want as long as it bounces straight up and doesn't go shooting off to the side. As long as it bounces back up, you're in great shape. And your goal is, if I drop it from this height, let's say I lose 50% of the energy. Your ultimate goal for the lab is if you drop it from higher and higher heights, will you lose more energy, less energy, or the same percentage of energy? So kind of keep that in mind as we're going through this. So you're going to have to design an experiment to do that, and I'll kind of walk you through it since this is the first one. So as I have written, the goal is to see how dropping the ball from higher heights affects the percent of energy lost. You will have to get creative for the materials you think you may need. I am lucky enough that I have meter sticks in my classroom that I can use, but if you don't have meter sticks or a tape measure or rulers, you can use anything you want. You can hold it up next to the side of your house and count the number of bricks up. So I drop it from 12 bricks, but it only bounces 4.5 bricks. So your measurement doesn't have to be a normal measuring device as long as it's consistent. So consistency is key for this. And the other part of that is not only does it have to be consistent, but you have to write down your units. So did you measure it in inches? Did you measure it in centimeters? Did you measure it in bricks? So it doesn't matter what you're using as long as you're consistent. You are permitted to research anything you think you need to learn about. So I wrote up here, you're calculating the percent of potential energy lost. If you think you need to look up what potential energy is, please feel free to do so. Learn while you're going through this. If you see any new terms, look them up. Find out what you're looking for. You have to drop it from at least 5 different heights. So I'm going to drop it from 12 inches, 24 inches, 36 inches, 48 inches, and 60 inches. I have 5 different heights. And that should be enough to give me a good graph to see if there is a trend and to see if dropping it from a higher height does result in more energy being lost, smaller percent of energy being lost, or the same percent of energy being lost. And at this point, you should also be making a prediction or hypothesis about what that's going to be. You have to calculate the percent difference for each drop height, but you only have to show your work for one of them. And I will show you how to do that calculation. I'll work through it with you step by step to make your life easy. All work can be documented on your paper or somewhere on your iPad. I personally recommend Notability. I think it's clean, neat, and easy and organized. But you use whatever works best for you as long as you meet all of the criteria I have. And the final copy should be written neatly or typed. If I can't read it, that is an issue. So I will go through what is due Monday and Tuesday, and I have that much more clear in the rubric. So if you go back to the front page, this is the rubric for what is due during the next class period. This is all of what's due for day 1 of your experiment. You have to submit a document containing the following, and please try to keep the sections organized. So have a title section, have a material section, have your name written clearly at the top, have a hypothesis section and tell me what your hypothesis is, have a data section where you include data in there, and have a calculation section where you do your calculations. So you must show all of your work for only one of your 5+ drops. So you only have to show work once, and I'll show you how to do that calculation and how to kind of set this up too. When you do your calculation, please always start with the base equation and work your way vertically downward. Because if you work your way horizontally, it's much easier to drop a unit or to drop a calculation. And I will try to model that as well as I possibly can. So in here, I have a blank document. First, I'm going to choose the pencil tool, and I am going to draw a setup of what the experiment will look like. I have it on the backboard. I did my own test, and I dropped it from 24 inches. That's my drop height. And it bounced back up to 8 inches. That's the bounce height. So you have a drop height that you drop it from and a bounce height that it bounces to. So on here, I will redraw that if I can draw a circle. Okay. And by the way, in Notability, if you draw a circle and leave it there, it will turn it into a circle for you, or a square, or a line. So you draw whatever you're trying to draw, hold your finger down on the spot until it forms the shape that you want it to form. So this is my drop height, and that was 24 inches. And I'm also going to label that as drop height, which I am going to denote with the variable height drop, h sub drop. So that's the drop height, because I'm going to have a couple of heights, so I want to be able to keep them, keep them separate. So that's my drop height. And then it's going to fall down to the ground. And it's going to bounce back up. And I'll draw it bouncing too. And then it will bounce back up to there. And this is, This is 8 inches. And that is the bounce height, which I'm going to denote as height sub bounce. So I'm just going to use a subscript so I can differentiate between the drop height and the bounce height. So that's my drop height, 24 inches, and my bounce height, 8 inches. From there, I'm going to make a data table with 3 columns, and because you have to collect at least 5 data points, 6 rows, 1 for your headers and 1 for each trial. So we're going to have trial 1, 2, 3, 4, 5. And I'm going to create some rows. And we're going to have a column for drop height. And you should put your units in there too. I measured mine in inches. Whatever you measure yours in, that should be there. So that's my first column. The second column should be bounce height. And that's also measured in inches. And my third column is going to be the percent lost, the percent energy lost, the percent height lost, and that's going to be measured in percent. So now we already know my first drop height. I dropped it from 24 inches. So I'm going to put in 24 inches, and my first bounce height was 8 inches. And you would repeat this 5 different times. You would do it from 24 inches, 30 inches, 36, 40. As long as you have 5 relatively varied heights, that's what I'm looking for. And then measure the bounce height. And when you're measuring the bounce height, it might be a good idea to drop it once, get a rough idea of where it is, and then drop it a second time and get a more accurate measurement. So really, I'm a little bit off. And the ball actually bounced to that height. So I hope you understand that I'm saying you can always double check your measurements by doing it a couple of times. So now we have a drop height and a bounce height. And now we can get started with the calculation, which should be relatively straightforward. And to do that calculation, the percent energy lost is equal to the percent of height lost. Or really, how many inches did you lose divided by how many inches did you start with? So that's going to be equal to the amount lost divided by the starting amount, or the initial amount, or the starting height. So the height lost divided by the starting height times 100%, so we can convert it into a percent. Where a percent is just a unit that gets carried through your work and does nothing else. We're going to take the amount lost divided by the height lost, divided by the height, starting height, to figure out what fraction we still have left, and then multiply it by 100. So for this first one, that would be 24 inches minus 8 inches, because that's how you figure out how much was lost. It's how much you started with minus how much you're left with, 24 minus 8, and that's going to be equal to 16. I don't want to jump too far ahead, but that will tell you how much height was lost during the bounce. And divide that by our starting height. And our starting height is that 24 inches. And don't forget to carry down, multiply by 100%. So now I'm going to do the denominator first, 24 minus 8, I'm so sorry, the numerator. We're going to do the numerator first, 24 minus 8, and we're left with 16 inches, and it's still divided by 24 inches times 100%. So I just carried this down again and carried this down again. So now 16 inches divided by 24 inches is going to leave you with a decimal equal to 0.667 times 100%. Carrying that 100% down, and now that I'm here, I can finally multiply 0.667 times 100, which is going to give you 66.7, and don't forget to carry your unit, 66.7%. And that's equal to the percent of energy lost. So now that we've worked through that entire thing, we can put it back into our data table. The percent lost with an initial drop height of 24 inches was 66.7%. I know that this is a lot, but I'm leaving this video here so that you guys can work back through it at your own pace. Pause. Think about how I went from step 1 to step 2. How did I go from line to line to line to line to line? Work your way through it with me. And hopefully that will guide you through it. And if you do have questions, please email me. And I think that pretty much wraps up the video. I hope this was helpful. And again, let me know if you have questions, and I will see you next time. Bye.